So, good morning everyone. Good morning, sir. My name is Rolanda Bangan Jr., student from the BE Smart E1 M1 section M1D. So, I'm here to present my reflection paper about the book of Ian Stewart called the title um, Nature Numbers. So, I chose the chapter 1 and this is my reflections. The chapter 1, the title the natural order. So the natural order is all about patterns. In the beginning of the book, Ian Stewart describes some of the nature patterns, such as the regular movements of the stars in the skies, the sixfold symmetry of snowflakes by Johanna Kepler, the stripe of the tiger and zebra, um, the recurring patterns of the sand dunes, um, rainbows, and the spiral of the snail shell, while nearly all flowers has petals arrangements in one of the following numbers: 5, 8, 13, 21, 34, and 55, 89, and so on. The regular patterns or rhythm made by humans, animals, um, scuttling, walking, flying, and swimming. From the examples of the patterns that is mentions, I ended thinking that patterns are basically numerical patterns, geometric patterns, and the movements patterns. Ian Stewart is the mathematician who is best known for bringing mathematics and science to the general people through successfully books, newspapers and magazines, articles, and radio, televisions, appearances. According to um, Ian Stewart, we live in the universe of pattern. Patterns have been recognized, classified, and used by the humans intellect and society through the systematic systems of thought it known as mathematics. We have discovered a big secrets by using mathematics to organize and systematize our views about patterns. Nature patterns are not merely there to be and admire. They are important pointers to the laws that controls nature processes. Um, 400 years ago, Johanna Kepler, Johanny Kepler, a German astronomer, um, published a short book called the Six Cornered Cornered Snowflakes as the gift of his sponsors. In it, he succeeded to that snowflakes can only be created by stacking small identical units together in a close proximity. Proximity. Kepler didn't conduct any test. Instead, he pondered different bits and piece of common knowledge. A sixfold symmetry of snowflakes was he's the major proof. Which he's a major proof. If you place a large numbers of an identical coin on the table and try to grow try to group them as closely as possible, you will get a honeycomb. So honeycomb arrangements in which every coin goes at the edge and it is surrounded by the six others and in perfect hexagons. So nature doesn't include a lot of beauty, which we can also see even if we don't have any mathematical um, expertise. So there is beauty in the mathematical stories. So that begin with heat and in fear um, in fear the underlying laws of regular regularities, but it is a different type of beauty because it applies to ideas rather than objects. So nature is the mathematics what evidence is to Sherlock excuse me Holmes pattern possess utility utility as well as beauty. So sorry. Assumptions suddenly and stand out once we learn to recognize background patterns. We're still figuring out how to detect new patterns. Humanity has just recently become aware of the two sources of patterns, currently known as the fractals and shadows, which are only barely years only 30 years old. Fractals and shadows are described in the non-linear system theory. Fractals are geometric shape or wave that reflect structures, and shadows is the unpredictable. Some of the examples of fractals are trees and leaves, seashells, lightnings, clouds, broccoli, and snowflakes. So nature loves strife and spots extend into an animal's kingdom, which with tigers and leopards, zebras and giraffes. So that's all my reflection papers about the chapter one called the natural order. Um, Chapter one of the book by Ian Stewart, the book um, Nature Numbers. Thank you.